For my next example, I would like to find the equation of a line tangent to the function f of x equals square root of 3x plus 1 at 1, 2. I want to find the equation of a line tangent to that function at 1, 2. I don't know, my function's something looking like this. I want to find the equation of that tangent line or something vaguely like that. Take a moment, push pause, and just copy down that problem. Well, to find the equation of a tangent line, here's what we're going to do. Equation of a tangent line. Well, a tangent line is really just any sort of line. I could use y equals mx plus b, but there's an easier way to get the equation of a line. Why don't we go from point slope form? Why don't we do y minus y1 equals m times x minus x1? Then I need to just find my x1, my y1, my m, and I'm good. So what's my x1? Well, my x1 is just 1. And my y1 is just 2. Really easy. What do I need, though, to find the slope of this tangent line? Well, I need the derivative. I need to go find f prime of x and then plug in 1. To get my slope, I need to find the derivative of that function and plug 1 into it. So that's going to take a little bit of effort. For right now, I'm going to say the equation of my tangent line, y minus 2 equals m times x minus 1. And as far as m goes, I need to find the slope of f when x equals 1. I need to find the slope of f when x equals 1, which means derivative. So I'm going to sort of put this tangent line problem on hold, and I'm going to go and I'm going to try to calculate my derivative. F prime of x equals the limit, as h approaches 0, of f of x plus h minus f of x over h. Okay, well, dealing with my particular formula here, I'm going to get the limit as h approaches 0 of plug in x plus h to the f function. Square root of 3 times x plus h plus 1 minus square root of 3x plus 1 over h. I'm going to clean this up just a little bit just by distributing my 3. And I'm going to get the limit as h approaches 0 of the square root of 3x plus 3h minus 1 over the square root of 3x plus 1. Sorry, this should have been a plus, not a minus. They should both be pluses. All over h. The limit as h approaches 0 of the square root of 3x plus 3h plus 1 minus the square root of 3x plus 1 all over h. I should probably plug in 0 for h, but if I do that, I'm going to get 0 on the top, 0 on the bottom. I need to do some simplifying with this limit because I'm getting 0 over 0. Do you remember a method from Unit 1 that'll help us? Hopefully, you said, or typed into Edpuzzle, rationalize the numerator. And that's exactly what I'm going to go do. I've got the limit as h approaches 0 of the square root of 3x plus 3h plus 1 minus the square root of 3x plus 1 over h. I'm going to multiply the numerator and denominator by square root of 3x plus 3h plus 1 plus square root of 3x plus 1. I'm multiplying by the conjugate of what I had. Denominator is 3x plus 3h plus 1 plus square root of 3x plus 1. Okay, so I'm going to get the limit as h approaches 0. Let's see. when I multiply this root by this root, it's the same thing. The roots kind of cancel. It's like I'm squaring a square root, and I'm going to get 3x plus 3h plus 1 when I do this multiplication problem. I'm going to cheat a little bit, because when I do this mess times this, and this mess times this mess, well, the two pieces are going to cancel. That's always what's going on, so I can kind of ignore that. Then I'm going to multiply this times this, and I'm going to get negative, the stuff that was in the square root, negative 3x plus 1. This is all over h times square root of 3x plus 3h plus 1 plus square root of 3x plus 1. Take a moment and see if you can finish this. Okay, so this is going to give me the limit as h approaches 0 of 3x plus 3h plus 1 minus 3x minus 1. I see things that are going to cancel there. Don't distribute in the denominator. I want to keep that h factored out because good things will happen if I do that. X's, the 1's cancel. We're going to get the limit as h approaches 0 of 3h over h times the square root of 3x plus 3h plus 1 plus the square root of 3x plus 1. The h's are going to cancel. We're going to get the limit. Oh, of course, make sure you're still being good with your limit notation. When we do have a quiz on this stuff, there will be another one of those rubric questions. Make sure you're being good. At this point, I'm going to go and I'm going to plug in 0 for h. 3 over square root of 3x plus 0 plus 1 plus square root of 3x plus 1, or 3 over square root of 3x plus 1 plus square root of 3x plus 1. Really, it's just two of those root 3x plus 1's, and I'm going to say f prime of x equals 3 over 2 root 3x plus 1. Next, I need to find the equation of my tangent line. I was almost there. I just had to find the slope, and I needed to find the slope of f when x equals 1. So I'm going to go and I'm going to plug in 1 for x in my derivative formula. I'm going to get f prime of 1 equals 3 over 2 times the square root of 3 times 1 plus 1. That's 3 over 2 root 4. That's 3 over 2 times 2. That's 3/4. So my tangent line is going to be y minus 2 equals 3/4 times x minus 1. Let me check this. So in Desmos, I want to check what I just did. I'm going to graph the original function, f of x equals the square root, the square root of 3x plus 2. And I see that point 1 comma 2 over there. I calculated my tangent line to be y minus 2 equals 3/4 times x minus 1. And what do you know? Perfectly tangent to that function right over there. Always nice when the graph does what we want it to do.